Welcome to UVU CS3060 Lecture 6.1, where I demonstrate a race condition. So let's get to the code. So I've created myself a directory here. It doesn't contain anything at the moment. What I'm going to do is I'm going to take the producer consumer and I'm going to whittle it down to its most basic function. So we're going to call this program sync.c. It's going to have standard I/O and pthreads. We'll go ahead and create our thread function. So we'll have an inc thread function. We won't fill that in quite yet. Let's finish our main. Won't use the main parameters, but we can put them in there for completeness. And really, what we're going to do is we're going to have a count variable. We'll initialize that to 0, and we're going to have that count variable looped through by two different threads. One thread is going to increment count, and the other thread is going to decrement it. We, of course, need thread handles. So we'll have a thread handle for increment and a thread handle for decrement. We will then do pthread create. And we'll send it in the increment handle to call the inc thread function with our count variable. And we'll do the same thing with decrement. Where we will have a thread that will decrement our count. We then will do pthread join on both threads. And we will print out our results. So let's create our thread functions. So we're going to have these thread functions loop. So let's go ahead and define our loop iteration. Let's just do 1,000,000. And what we'll do in here is we will go ahead and cast our function parameter, thread function parameter to an integer. We'll also have ourselves a loop variable, and we will loop through that as many times as we specify there. And all we're going to do in here is increment our count. And of course, because it's a thread function, we need to return something. We'll just return null. And let's go ahead and copy that and paste it. This time we're going to create our decrement thread function. And our decrement thread function is going to decrement. So there we go. Let's go ahead and write that. We're going to quit. Now I'm going to type in a make, but I'm going to add C flags. Specifically, I'm going to have it do pthread with debug. And I'm going to add another option in here called save temps. And you'll see shortly why. Make sync. All right. So let's run this and see what we get. Now, do note that our thread functions loop the same number of times, 1,000,000 times, and they both increment and decrement. So what we're checking here is, can we get count to add 1,000,000 times and subtract 1,000,000 times simultaneously and still come out with a 0? So let's go ahead and clear this screen and run our program. No, for some reason, 782,000 times increment. Here we have negative 874,000 times. I use save temps because it allows me to create from my source code file not only the program file but 3 other files. You have your preprocess file, which is sync.i. You have your assembly file, which is sync.s, and you have your object file, which is sync.o. I'm going to take a look at sync.s. Now this is going to get us into assembly language here, but this is what we want to do. We want to examine what the actual machine instructions are for this. Here's our inc thread function, and here are the assembly instructions for it. There's lots of everything with a dot in front of it is debug information. We're just going to ignore that. Now, most of this portion up here at top is just initialization. But this is where it really matters for us, where we move a value from local variables, so anything that's being indexed from RBP is a local variable, into RAX. This is the address to count from the main function. RAX now contains the address. We dereference that address and load its value. So whatever the value of count goes into EAX here. We then perform an addition operation. This is kind of a funny way that compilers like to do addition operators. We're adding 1 to the value of RAX, or count. We're again loading that address into RAX, and we're moving the result of that addition into the pointer. It took us 5 instructions just to increment that one variable. During those 5 instructions, we can see the result. Again, if we run the sync program, we're going to get a different result almost every single time because the scheduler is interrupting sync during that particular 5 instructions. This is the race condition that we're dealing with. This is the race condition we need to solve, and we will over the course of these lectures. This brings us to the end of lecture 6.1, where I demonstrate a race condition.